Hello, folks, and welcome to another update on the situation in Iceland. Today is November 20th. It is about 10:30 in the morning here Mountain Standard Time. That would make it about 5:30 p.m. over in Iceland. Thanks for joining me. I'm geology professor Shawn Willsey. Appreciate all that have been supporting and encouraging me to continue to do these updates. I know there's a lot of places you could go to get your information about what's going on in Iceland, and I do appreciate you coming here. I also know that there can be apparently there can be a lot of misinformation or some conflicting information. And so just please know that I'm doing my best to make sure I'm getting the most accurate and up to date information that I can. Also recognize that I'm based here in the States, and so that may be a little bit of a barrier. And also realize that I pride myself on doing a good job of separating observations and what we know, the data, from interpretations or opinion or hypotheses. And so I'll try really hard to make sure I delineate those two things. So let's get right into it today. The other thing real quick is that I'm going to make this update a separate video than the Q&A, the questions and answers that a lot of people have been enjoying. There's a lot to get to today. And so I think I'll separate that at least for now, and we'll just see how that is moving forward. I've heard from people either way. Some people like the big long videos with the question answer. Other people want it kind of short and sweet and keep those separate. Ultimately, I trust that you can navigate YouTube, fast forward things, and skip ahead and do what you need to do there, and that's fine. But I appreciate you for coming in here. So let's jump right into the data. As today is Monday, we've had some significant updates that have happened over the last 48 or so hours, most notably this one this morning from the Met Office. So let's go through their announcement for today and look at some of the highlights here, and then we'll look at some of their maps, get to the quake data, look at the ground deformation data, a couple news information items that I think are worth looking at and investigating. And then at the end, I've got a cartoon, probably a poorly drawn cartoon that I've drawn, very simplified, that might help some people visualize what's been happening over the last 2 weeks. And so we'll see how that goes. So, okay, so the earthquake data for the most part over the weekend was similar to what we saw with 1,000 plus earthquakes per day. That has changed over the last few hours, and I'll get to that here in a second. But just kind of scrolling down, I'll get to this diagram as well. The biggest thing that's happened over the weekend is they got the latest INSAR data, so ground deformation data showing how the land has changed position. And just between November 18th to 19th, they have evidence, and you can see that here and also here, I can show it to you now, that there's been considerable uplift just over the weekend. And so you can see in the red here, that would be about 30 millimeters of uplift in 24 hours. That's pretty notable. That's 3 centimeters, a little over an inch if you're using those units. And it's happening in the region back over here by the power plant in the Blue Lagoon. So we've been focusing over here from Grindavik and up into the Sundunukur crater system in this area, but now it's shifted back this way, which for some of you might be like, what is going on? This seems so confusing. Earthquakes here, earthquakes there, uplift in different places. I'll try to make some sense of it for you here in a second. But let's go through their update here and see what things we can glean from it. So the rapid ongoing uplift close to Svartsengi, that's the power plant, is occurring in the same area where they had uplift prior to the intrusion on November 10th. So if you remember early in November, if you can think back that far, we had uplift in this exact same area. That was one of the initial signs along with the earthquakes that something was happening underground, something significant. And then everything shifted over to the east. We formed the big magma intrusion. The big earthquakes rocked Grindavik. We saw the subsidence occurring there and the cracks in the ground. But now we're seeing some uplift back in that initial area. Geodetic models derived from satellite images show that the uplift in Svartsengi is considerably faster than before. So the rate of deformation, how quickly the ground is moving over a period of time, is much faster, which is significant. Crustal uplift in the Svartsengi region due to magma accumulation at depth has been measurable since the intrusion began on November 10th. Okay, we knew that. Initially, the uplift sign was influenced by the formation of the intrusion, but now the dominance of deep magma recharge is apparent. So basically, the initial uplift was forming the initial intrusion, but now what they're saying is like, okay, more magma's coming into the system. This latest round of uplift near the power plant over this past weekend is a good indicator that the system, the shallow magma system, is getting more fresh magma from a deeper source. The clear sign of crustal uplift does not change the likelihood of an eruption from the magma intrusion. Okay, so that's keeping things the same. Um, this is assessed, among other things, on the fact that the Earth's crust over the magma intrusion is much weaker than the crust over the uplift regions of Svartsengi. I paused on that sentence for a while this morning and would love to know maybe some of the basis and the rationale behind that statement. So they're saying that where we're seeing the earthquakes over here to the east, where the intrusion is, the dike, that those rocks are weaker than the area around the power plant. And I guess they're just basing that on earthquakes. As long as there's not significant seismicity in the Svartsengi region, remember that's the power plant, there is not a high likelihood of an eruption at that location. And I would agree with that. Until we get the seismic signals, the earthquakes that would show us that magma is not only uplifting the crust there, but moving that magma up towards the surface. Right now, as the data sits, I would not, we're not forecasting an eruption around at or around the power plant right now. But of course, those things can change quite quickly. Let's see what else we got here. Moreover, an eruption is still deemed more likely from the intrusion, particularly if there is a sudden large inflow of magma into the intrusion. When I get to my cartoon here at the end, I think that'll make more sense. So what they're saying is more magma is coming up into the system under the power plant, but we don't think it's going to erupt there. We think that magma is going to travel to the east into the intrusion, into the dike, and that's the place where the eruption would be if there is one. And so hopefully that makes sense. I know sometimes reading these updates, it's easy to get a little bit lost and confused with all the verbiage and such. So at least that's how I interpret it. Realize that I'm going from an originally Icelandic report written in Icelandic language, translated into English, maybe by AI or Google Translate. But as I read this in English, which is the only language I can really navigate with, that's how I interpret things. So anyway, so there's the diagram, the map that shows some of the uplifted area there. And so yeah, we're just seeing uplift in this area and upwards of 3 centimeters in basically 24 hours or so. That's pretty remarkable. So okay, what else do we have? So the other thing that came out from the Met Office was a hazard map, and these are really valuable. This is something that's put out not just for volcanic eruptions. You might do these for earthquakes. You might do them for flood zones. Just a really valuable tool that allows public officials to really get a sense of what areas need to be monitored or possibly mitigated from whatever disaster or hazard we're looking at. In this case, obviously, we're looking at a volcanic eruption, and it is written in Icelandic, but I've got some crude translations here that should be helpful. So basically, in the orange here is they have hazard zone A, and in hazard zones A, this is just where they're considering that there's a good chance of earthquake hazards. So strong shaking from earthquakes in the orange zone here, hazard zone A. Hazard zone B, which more or less straddles the magma intrusion, which runs from off the coast just southwest of Grindavik and up to the northeast here. Hazard zone B is not only a hazard of earthquakes and strong shaking from earthquakes, but also cracks opening in the ground, volcanic fissures erupting, volcanic gases escaping. And so this would be, those are the hazards that would exist within that zone. And then the purple here, this is their area of most concern. Hazard zone C is basically the same as B, but with the greater chance of gases being quite concentrated, such that having a gas meter, something that measures the amount of carbon monoxide or sulfur dioxide in the air, and even wearing a gas mask on your face would be wise. And so this might just be something, I mean, right now, most of the area shown on this map is not accessible to the public. So this isn't necessarily for the public, but this might be something, at least at this point, that they're using for their emergency response teams. Other, we have construction crews around the Blue Lagoon trying to put together that embankment, that wall to protect some of the infrastructure there. So we do have people in Iceland in this zone continuously, even though we've evacuated the town. And so these hazard maps are helpful. And these hazard maps can change as the data changes and maybe the earthquakes change. And so this is a way for the scientific community to take their information, make their best inferences, pass that on to public officials, and then the public officials can manage public safety and other sorts of things like that as best they can. So the lines on here are either subsidence features, places where the ground has collapsed. We've been calling those grabens. That's fine. They've also called them sickle valleys, and there's other sort of translation terms in there, and these, and also cracks, so tension cracks, ground fissures in the area. So there's that hazard map from the IMO office. If we look at the quake data over the last 24 hours or so, magnitude 0 and above, we see that still that strong northeast southwest trend over here. Still a few quakes over here near Klevervatn and Krusjevik, this geothermal area in this part of Iceland. But again, I feel like those are mostly just triggered quakes. That those are not related directly to a magma body. And then what's interesting here to me, so if we just look at the magnitude 2s over the last 24 hours, you can see those there. So again, they're mainly concentrated around Hagafell, which is just south and east of the power plant, quite close to it, just east of the road there. And then there's a little clustering here further up into the crater system. But then what's interesting is, so that's magnitude 2 and above over the last 24 hours. But then if we just look at the last 12 hours, we only get one magnitude 2. And if we look at magnitude 1 quakes, that's for 12 hours. There's not that many. You could probably count them all. There's maybe like a dozen there. And then if we just look at the last 6 hours, there's only 3. And even if we drop this down to magnitude 0, there's just not a lot of quakes happening. So right now, as I record this, there's the last 3 hours. So only 2 quakes, 0.4 in magnitude and a 0.3 in magnitude in the last 3 hours. So as I record this here at this time, there's a bit of a lull. Doesn't mean anything's about to happen, but it's interesting. We'll have to see if this seismic lull persists in the short and long term. Quakes could pick back up within an hour or so, and everything could be back to background levels. But right now we're seeing reduced seismicity than what we've seen, I'd say, for the last 2 weeks. It's probably too early to say if it's significant or not, but just something to make note of. The GPS data, if we look at, let me zoom this out just a bit here so you can see, oh, that's not out. The GPS data. So this is, let's look at the station closest to Grindavik. And this nicely shows everything that's been happening. Let's simplify these by just looking at the Uplift graph, this last one here. So this is, and let's do, yeah, 90 days is the best I think we can do on this one. But there's, everything's normal in September, and going into the end of October, we see uplift occurring, and then this quick drop, which happened about the 11th or 12th of November, this past weekend before this previous weekend. And that's when we started seeing the big cracks opening in the ground and Grindavik actually start subsiding and sinking upwards of a meter or so in this case. And then you can see things starting to level back out there. And so if we look at some of these other ones here, this is near the power plant. This is kind of interesting here. So initially, this station started moving north, then it dropped and moved a little bit south, and then it took off and started moving north again, presumably again as that magma intrusion started to grow. And you can see the trend is continuing here, so the uplift is going on there. Interesting plot with the east-west one, a big movement again. 11th and 12th, that was the big day where things really started moving, no matter which way you look at it. So some of the GPS data there for what it's worth. Okay, and then just a few news items that I thought were kind of interesting. So this news site here, VF, again, I don't know much about the news agencies, but so we'll take them with a grain of salt. Inflow of magma at up to 10 times the speed. And so this is the Volcano and Natural Hazards Group of Southland. So again, I don't know much about these organizations, so we'll just but we'll just take it as a bit of information. On November 10th, a large amount of magma flowed from the sill into the indentation that went under Grindavik. So that's the big intrusion there. And as a result, the land above the sill was very viscous. The conditions in the Earth's crust now are therefore favorable for magma to flow again, and it has therefore been suggested that the inflow is now up to 10 times faster than before November 10th. And I've seen this similar data on a couple other places. I just didn't put them on here. But basically, the rate that the magma is flowing in, the ground deformation is occurring at such a rapid rate that when they model how much magma is coming in to cause that deformation, they're seeing that it's 10 times the rate that we saw a little over a week ago, the weekend previously. And so that's significant. Again, it doesn't necessarily mean the eruption is about to happen. It's showing that there's more magma moving into the system. Um, let's see what else. This I found was kind of interesting here, and so this is from Ruv, another news source in Iceland, and this particular volcanologist, Arman Höskuldsson, I've seen a few things from his, and I just want to maybe comment on what he's saying. So his um, interpretation of where the magma is likely to erupt is actually at Elvorp. And so let me show you where that is, and let's talk about that a little bit. So he thinks, and he's been saying this from the beginning, that an eruption, if there is to be an eruption, he thinks it's going to come from this existing row of craters over here. And I'm just curious as a fellow geologist as to what basis he has for that. I'm not saying he's wrong. I would just like to know what the data is that supports that, because even though it's kind of on the edge of where this uplift's taken place, there hasn't been a lot of seismic activity over here. There's really nothing to suggest that the magma has moved over there or is moving over there. Now that can change, but I think I bring it up again not to nitpick someone's hypothesis, but mainly just to show that I think is especially people in Iceland, as they pick up their news reports, it can be confusing. You can read even geologists sort of take on the situation, and you end up with very different conclusions or interpretations of the data. So I see why it seems a bit confusing. I mean, the bottom line is no one knows exactly, right? No one could say for sure, oh, it's going to erupt here. I think following though the breadcrumbs and the seismic signals and everything else we're seeing, I think something along or close to the orange line we've shown here is most likely to be the case. Let's see, what else do I have in the queue for you? So I found that was kind of interesting. In terms of some of the construction work that's going on, that continues. So they're working round the clock. The bulldozers, the backhoes. I mean, it's just a full-scale operation. So there's Grindavik in the background. This is the road coming into it. And so they're working in that saddle area just south of the power plant to build up. They're collecting material from local hills and sources. You can see the very dark basaltic cinders and rock and soil that they're using to build up some of these embankments. So there's a series of pictures here. So that work's continuing. There's the power plant. So they're right in this saddle here is where they're trying to, that's either where they're collecting the material, that might actually be where they're putting the embankment in. It might be a little bit further down the hill. So anyway, that work continues there. And then the last little news item I have here is that they have started to drill a new water well out near the airport, near Keflavik, that will be a cold water drinking supply. So I don't know the details about that, how deep it goes, how long it's going to take, but basically the Blue Lagoon area, the power plant, supplies a lot of heat, electricity, and drinking water to 30,000 or so people on the whole peninsula in this whole region here. And with that potentially being at risk, they're starting to put together some contingency plans, some backup plans. So somewhere in here is where they're drilling that drinking water well, and that will help supply water to these areas here. So anyway, a couple things I found to be interesting, and I hope you did as well. So we'll conclude here with my cartoon. Please be kind as you critique this terrible work of art, but I hope it's effective in conveying a little bit about what might be going on. Again, this is just totally my interpretation, not not the de facto end all be all. But this is a simple cross section of the area. So from west to east, okay. There's east over there. I guess it doesn't quite go that far. And what we have here is the surface of the ground. So this is a slice through the earth, looking at it in profile. The Blue Lagoon, the power plant, the two dots up here. The Sundanukur crater row would be over in this region here. So essentially what I've done is taken a more or less east-west slice through the ground somewhere about like this. So something, imagine a cross section more or less along that yellow line there. And that's what I've drawn here. Not to scale, totally cartoonish, did this in less than 10 minutes. The X's are meant to be earthquakes. So what we had happen at the end of October up to about November 10th or so, and the dates are maybe plus or minus, so don't hold me to those, is we presumably had magma intruding underneath the power plant in the Blue Lagoon. We saw earthquakes beneath that area. We saw uplift. And that was the data that was the initial sort of signal, the alarming signal that something strange, not seriously strange, but something new, there was some sort of new geologic event possibly taking place beneath that area. So that was the case there. If we move forward in time now, so I'll show you another cross section, but we'll move forward in time. So the red's meant to indicate the magma body, again, very cartoonish. The black X's are just earthquakes. So as the magma is intruding into these existing rocks, it's breaking rock, making space for the magma to move up and generating earthquakes. Most of those earthquakes are around the magma body itself. You might get some over here because they're experiencing the stress of the magma pushing in. I threw an earthquake in over there. I think you get the idea. So let's move forward to November 11th to 17th, about a week or so ago. Then what happened was that magma worked its way to the east. And I draw it here as kind of going up a little bit of a ramp. It might have moved mostly horizontally. Again, don't critique the fine details here. We're just kind of looking at the big picture. And what we saw over here then was this was what they're calling the magma tunnel, or we've called the magma dike or the intrusion, the big orange line that I have drawn across my Google Earth image that runs from just near Grindavik and up to the northeast. So the magma moved to the east, intruding a new area, breaking rocks as it went, moving its way towards the surface, creating this more or less vertically oriented magmatic dike, and again all the earthquakes associated with that. We think that magma body got to within 800, maybe as shallow as 500 meters of the surface, but didn't obviously quite get to the surface because we did not have an eruption there. Why did the magma not get there? Ultimately, it's how much magma and how much of that magma was under pressure in terms of the volume of magma and the amount of dissolved gases in the magma, possibly combined with the types of rocks and the strength of the rocks sitting over the top of this. And I wouldn't even try to speculate. I mean, there's so many. So even though it's all the same rock composition as we looked at with the borehole data previously, there's fragmented basaltic layers, there's lava flows that are very cohesive and robust, there's maybe layers of ash that might be more soft. So there's a lot of heterogeneity, like a lot of discontinuities in the rock layers themselves. But for whatever reason, that magma just didn't quite get to the surface. So that gets us through about the 17th or so, which was just at the end of last week. And then we have this weekend's data and what's taking place today. And this, of course, was uplift in this area. Okay. So also, I didn't draw the arrow in here, but right at the center of the dike, there was actually a little bit of subsidence or the ground moving down. And then if we move forward to today, this is more or less what we are interpreting the situation as. So more magma coming in, so more magma is coming up into the system underneath the Blue Lagoon and the power plant. That's causing this area to rise. Somehow, though, it's not generating earthquakes here. And they're attributing that to the strength of the rock above it. Could be that it's thicker. Could be that it's just a stronger substrate of material, that it's not able to break the rock as it pushes up. Instead, it's just pushing it up. It's doming the entire rock set above it. And instead, we're seeing that. So that's what's happening today. And that might mean, and I put a big question mark here, that if that magma continues to come up from deep, if it's not going to go anywhere vertically above it, then its path of least resistance would be to travel up into this region that it's already created. This rock has shown itself to be somewhat weaker. And the question is the magma pressure coming into the system going to exceed the strength of the rock above it? Because if it does, we will have an eruption. Maybe later today, maybe tomorrow, maybe a week or two from now. But this is not sustainable. If you keep pumping magma into this plumbing system, and this is going to be the weak spot, something's got to give at some point. On the contrary, you might pump some magma in, but then that flow of magma might dissipate a little bit, and you could end up with this thing somewhat being at a stalemate and just staying down there and beginning to solidify. So anyone's guess what's happening right now. So I don't know if that was helpful to you, but there's my very silly cartoon of possibly what's happening here in Iceland. Maybe I'll modify this as we go. Thanks for sticking with me with that. Hopefully that makes sense. I did throw, a couple earthquakes out here, just over those ones over towards Klevervaten. So anyway, but hopefully that helps, friends. That's the update for today. I'll try to put together a video as well of just question and answer. That might pertain a lot to Iceland questions, but sometimes we also have questions in there that are more general and generic in terms of just geology questions, plate tectonics, different things of that nature. So thanks so much for joining me. Thanks for your support, whether that's financial or just encouragement. If you have really pertinent questions, you can continue to put those in the comment section. If you put them in all caps, which I know is obnoxious, it just helps them catch my attention. If there's another way to do that, I don't know if you can do like a at and then my name, Shawn Willsey, and that might pop out too. But when I'm going through hundreds of comments, it does help if there's something that breaks it up and kind of catches my eye. So otherwise, stay safe, be well. For the good folks in Iceland, we are still thinking of you. We are still monitoring what's happening on your amazing little island, and we will continue to do so. We're concerned about your well-being, and we hope that you can settle into this new normal, and we hope that it's a short-term new normal, especially for the folks from Grindavik. We hope that there's some resolution coming your way, and that by this summer you can be back in your homes. But we'll just see what nature throws at us, and we'll roll with the punches. So thanks again, and have a great day, and we'll see you next time.